Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math P4, Variant 2, May-June 2018. Let's get started. Here is a list of ingredients to make 20 biscuits. Find the mass of rice as a percentage of the mass of sugar. When setting up the percentage equation, the value after the of, which in this case is the mass of the sugar, would be the denominator. So we have the mass of the rice, which is 425 grams divided by 500 grams times 100%. This gives us 85%. Find the mass of butter needed to make 35 of these biscuits. If 260 grams of butter is needed to make 20 biscuits, then what mass of butter will be needed for 35 biscuits? This is what we are calling x. When we cross multiply and make x the subject, this is what we have, which is equal to 455 grams. Michelle has 2 kilograms of each ingredient. Work out the greatest number of these biscuits that he can make. The flour is the ingredient with the greatest mass to make a biscuit. This means the flour is the limiting ingredient, which would help us determine the highest number of biscuits Michelle can make. So first, we need to find the mass of flour required to make one biscuit. To get this, we divide 650 grams by 20, which gives us 32.5 grams. So now to get the number of biscuits we can make with 2 kilograms of flour, we divide 2 kilograms, which is the same as 2000 grams, by 32.5 grams, which is equal to 61.5. This means the greatest number of biscuits Michelle can make is 61. A company makes these biscuits at a cost of $1.35 per packet. These biscuits are sold for $1.89 per packet. Calculate the percentage profit the company makes on each packet. The percentage profit on each packet would be equal to the profit made on each packet, which is 1.89 minus $1.35 divided by the cost incurred in making a packet, which is $1.35 times 100%. This gives us 40%. The selling price of $1.89 has increased by 8% from the last year. Calculate the selling price last year. If the selling price has increased by 8%, then we add 8% to 100%, giving us 108%. So we have 108% of the original price, or the price for last year, is equal to $1.89. When we make the original price the subject, this is what we have, which is equal to $1.75. Over a period of 3 years, the company's sales of biscuits increased from 15.6 million packets to 20.8 million packets. The sales increased exponentially by the same percentage each year. Calculate the percentage increase each year. In this case, we need to apply the compound or exponential formula. R represents the annual increase, so we need to make R the subject. When we make R the subject, this is what we have. Big A represents the final sales value, which is 20.8 million. Small a represents the initial sales value, which is 15.6 million. T is the time duration, which is 3 years. When we type this into the calculator, we get 10.1 rounded to 3 significant figures. The people who work for the company are in the following groups. The ratio of the number in Group A to the number in Group B is 7 is to 10. The ratio of the number in group B to the number in group C is 4 is to 3. Find the ratio of the number in group A to the number in group C. Give your answer in its simplest form. We've been given the ratio of group A to group B as 7 is to 10. We've also been given the ratio of group B to group C as 4 is to 3. Group B is common in both ratios, so we need to make sure the value for group B is equal for both. To do this, we multiply through the first ratio by 2. This gives us 14 is to 20. Then we also multiply through the second ratio by 5. This gives us 20 is to 15. So now we have 14 is to 20 is to 15, which cannot be simplified further. For our answer, we need to only provide the ratio for group A to group C, so that will be 14 is to 15. There are 45 people in group C. Find the total number of people who work for the company. The number of people in group C, which is 45, is equal to the ratio share for the people in group C, which is 15, divided by the total ratio, which is 14 plus 20 plus 15, times the total number of people. 14 plus 20 plus 15 is 49. When we make T the subject, we get 147. The time taken for each of 120 students to complete a cooking challenge is shown in the table. Write down the modal time interval. The modal time interval is the interval with the highest frequency. The highest frequency is 44. The time interval for this frequency is T is greater than 20 and less than and equal to 25. Write down the interval containing the median time. To get the position of the median, we use the formula half n plus 1, where n in this case is 120. This gives us 60.5. The frequency for the first interval is 44. 44 plus 32 is 76. This means the median lies within this interval, which is T is greater than 25 and less than and equal to 30. Calculate an estimate of the mean time. The mean is equal to sigma f of x, which is the total time taken by the students, divided by sigma f, which is the total number of students. We've not been given the specific amount of time taken by each student. Instead, what we've been given are the different ranges of the times taken. So we need to find the midpoint value for each of the time intervals. So for the first interval, the midpoint time is 20 plus 25 divided by 2, which is 22.5. Then we have 25 plus 30 divided by 2, which is 27.5. 30 plus 35 divided by 2, which is 32.5. 35 plus 40 divided by 2, which is 37.5. 40 plus 45 divided by 2, which is 42.5. So for sigma f of x, we have 22.5 times 44 plus 27.5 times 32 plus 32.5 times 28 plus 37.5 times 12 plus 42.5 times 4 minutes divided by the number of students, which is 120. When we type this into the calculator, we get 28.3 minutes rounded to 3 significant figures. A student is chosen at random. Find the probability that this student takes more than 40 minutes. This probability is equal to the number of students who take more than 40 minutes, which is 4, divided by the total number of students, which is 120. This simplifies to 1 over 30. Complete the cumulative frequency table. The number of students who spent less than 30 minutes is 44 plus 32, which is equal to 76. The number of students who spent less than 35 minutes is 76 plus 28, which is equal to 104. The number of students who spent less than 40 minutes is 104 plus 12, which is equal to 116. The number of students who spent less than 45 minutes is 116 plus 4, which is equal to 120. On the grid, draw a cumulative frequency diagram to show this information. On the grid, we plot the points in the cumulative frequency table and connect the points with a smooth line. Find the median time. To get the median, we map half of 120, which is 60, on the diagram. This gives us the median to be 27.5 minutes. Find the interquartile range. The interquartile range is equal to the upper quartile minus the lower quartile. To get the upper quartile, we map 3/4 of 120, which is 90, on the diagram. This gives us 32.5 minutes. To get the lower quartile, we map 1/4 of 120, which is 30, on the diagram. This gives us 23.5 minutes. 32.5 minus 23.5 is equal to 9. Find the number of students who took more than 37 minutes to complete the cooking challenge. On the diagram, when we map 37 minutes from the horizontal axis to the cumulative frequency graph, we get 110, which is the number of students who took 37 minutes or less. Therefore, to get the number of students who took more than 37 minutes, we subtract 110 from the total number of students, which is 120. 120 minus 110 is 10. Draw the image of triangle A after a reflection in the line x equals 2. So first, we draw the line of reflection, which is x equals 2. Then from here, we need to reflect the vertices of triangle A in the line x equals 2. So for point B on the triangle, since we move 1 unit to the right to touch the line of reflection, we also need to move 1 unit to the right from the line of reflection to pin the new position of point B. We need to repeat the same process for points A and C on the triangle as well. When we are done, we are able to map out the reflected image of triangle A. Draw the image of triangle A after a translation by the vector -2, 4. For this translation, the translation vector dictates that we move each of the vertices of triangle A 2 units to the left and 4 units upwards. On the diagram, the movement for point C has been shown. After repeating the same process for all the other points as well, we are able to map out the translated image of triangle A. Draw the image of triangle A after an enlargement by scale factor -half, center 3, 1. First, we need to mark the center of enlargement. Then we need to move each vertex on triangle A such that we are able to reproduce the enlarged image of the triangle. Let's pick point B. To move from the center of enlargement to point B, we move 2 units to the left and 4 units downwards. And so to pin the new position of point B, we move in the opposite direction due to the negative scale factor. So instead of moving to the left and downwards, we move to the right and upwards. Since the scale factor is half, we move half the number we moved initially. So to pin the new position of point B, we are going to move 1 unit to the right and 2 units upwards. After repeating the same process for all the vertices on triangle A, we are now able to map out the enlarged image of triangle A. Describe fully the single transformation that maps triangle A onto triangle B. When we look at triangles A and B, we can tell straight away that this is a rotation 90 degrees in the anti-clockwise direction. So now we need to identify the center of rotation. For a 90-degree rotation, the way to determine the center of rotation is this. We draw a line to connect at least two corresponding points on both triangles A and B. Then we need to draw the perpendicular bisectors of these lines. The intersection point of the bisectors is the center of rotation. In this case, the point has coordinates -6, -2. And so the full description for this transformation will be rotation 90 degrees anti-clockwise about the center -6, -2. Describe fully the single transformation represented by the matrix 0, -1, -1, 0. This matrix represents the transformation reflection in the line y equals -x. Simplify 3p squared all raised to the power 5. By applying the laws of indices, we can rewrite this as 3 raised to the power 5 times p squared all raised to the power 5. 3 raised to the power 5 is 243. The powers of p multiply, so we have p raised to the power 2 times 5. 2 times 5 is 10, so we have 243p raised to the power 10. Simplify 18x squared y raised to the power 6 divided by 2xy squared. 18 divided by 2 is 9. X squared divided by x is the same as x raised to the power 2 minus 1, which gives us x. Y raised to the power 6 divided by y squared is the same as y raised to the power 6 minus 2, which gives us y raised to the power 4. So we have 9x y raised to the power 4. Simplify 5 over m all raised to the power -2. By applying the laws of indices, we can rewrite this as 5 raised to the power -2 divided by m raised to the power -2. 5 raised to the power -2 is the same as 1 over 5 squared. 5 squared is 25, so we have m squared over 25. In this part, all measurements are in meters. The diagram shows a rectangle. The area of the rectangle is 310 meters squared. Work out the value of W. Here is the formula for the area of a rectangle. When we make W the subject, this is what we have. We've already been given the area as 310 meters squared, so we need to find the length of the rectangle. The length of the rectangle has been given as 5x minus 9 and 3x plus 7. This means 5x minus 9 should be equal to 3x plus 7. When we group like terms, we get 2x equals 16. And when we divide both sides by 2, we get x equals 8. So to get the length, we plug in the value of x in either 5x minus 9 or 3x plus 7. In this case, we went with 3x plus 7, so we have 3 times 8 plus 7. When we type this into the calculator, we get 10. The diagram shows a design made from a triangle AOC joined to a sector OCB. AC is 8 centimeters, OB equals OC equals 7 centimeters, and angle ACO is 78 degrees. Use the cosine rule to show that OA equals 9.47 centimeters, correct to 2 decimal places. When we apply the cosine rule to triangle AOC, this is what we have. When we make OA the subject and plug in the values of OC, AC, and angle ACO, this is what we have. When we type this into the calculator, we get 9.4717 centimeters, which is approximately 9.47 centimeters, rounded to 2 decimal places. Calculate angle OAC. To get angle OAC, we apply the sine rule to triangle AOC. This gives us sine of angle OAC divided by 7 centimeters equals sine 78 degrees divided by 9.47 centimeters. When we make angle OAC the subject, this is what we have. When we type this into the calculator, we get 46.3 degrees rounded to 1 decimal place. The perimeter of the design is 29.5 centimeters. Show that angle COB equals 41.2 degrees correct to 1 decimal place. The perimeter of the design is simply the distance around the shape of the design, and that is equal to OA plus AC plus OB plus arc BC. We've been given the perimeter as 29.5 centimeters. OA is 9.47 centimeters. AC is 8 centimeters and OB is 7 centimeters. The length of arc BC is theta over 360 degrees times 2 pi r, where r is 7 centimeters and theta is angle COB, which is what we are finding. 9.47 plus 8 plus 7 is 24.47. 2 pi times 7 is 14 pi. When we subtract 24.7 from both sides, this is what we have. And when we make angle OCB the subject, this is what we have. When we type this into the calculator, we get 41.17 degrees, which is approximately 41.2 degrees rounded to 1 decimal place. Calculate the total area of the design. The total area of the design is equal to the area of triangle AOC plus the area of sector OCB. The area of triangle AOC can be found using the formula half AB sine C, where A and B in this case are 7 centimeters and 8 centimeters, and angle C is the angle between these two sides, which is 78 degrees. The area of sector OCB can be found using the formula theta over 360 degrees times pi r squared, where theta is 41.2 degrees and r is 7 centimeters. When we type this into the calculator, we get 45.0 centimeters squared, rounded to 3 significant figures. Complete the table of values for y equals x cubed over 3 minus 1 over 2x squared, where x cannot be equal to 0. When we plug in x equals negative 0.5 into the equation, we get y equals negative 2.0 rounded to 1 decimal place. For x equals 1, we get y equals negative 0.2 rounded to 1 decimal place. For x equals 2, we get y equals 2.5 rounded to 1 decimal place. On the grid, draw the graph of y equals x cubed over 3 minus 1 over 2x squared for x is greater than and equal to negative 3 and less than and equal to negative 0.3, and x is greater than and equal to 0.3 and less than and equal to 3. So on the grid, we plot all the points in the table and connect the points with a smooth line. By drawing a suitable tangent, find an estimate of the gradient of the curve at x equals negative 2. On the grid, we draw a tangent to the curve at x equals negative 2. Then we pick 2 points on the tangent, which we are going to use to estimate the gradient. By applying the gradient formula, we have the gradient m as 7.2 minus negative 2.8 divided by 0 minus negative 2, which is equal to 5. Write down the equation of the tangent to the curve at x equals negative 2. Give your answer in the form y equals mx plus c. All we need to do is find the values of m and c and plug in these values into y equals mx plus c. We found m in the previous question as 5. To get c, we pick the point on the y-axis through which the tangent passes, which is 7.2. So we have y equals 5x plus 7.2. Use your graph to solve the equations. X cubed over 3 minus 1 over 2x squared equals 0. To solve this equation using the graph, we need to find the x-coordinate of the intersection points between the curve and the line y equals 0, which is the x-axis. On the grid, the x-coordinate of this point is 1.1. For this equation, we need to first rewrite it to leave the function of the curve on one side of the equation. This means the line we need to draw is y equals negative 4, and we need to find the x-coordinate of the intersection point between the curve and the line y equals negative 4. On the grid, we've drawn the line y equals negative 4, and the x-coordinates of its intersection points with the curve are negative 2.2, negative 0.38, and 0.35. The equation x cubed over 3 minus 1 over 2x squared plus 4 equals 0 can be written in the form ax raised to the power n plus bx raised to the power n minus 3 equals 0. Find the value of a, the value of b, and the value of n. To write the equation in the given form, we first need to clear the denominators of the equation by multiplying through the equation with 6x squared. This gives us 2x raised to the power 5 minus 3 plus 24x squared equals 0. We can rearrange the terms in the equation, so we have 2x raised to the power 5 plus 24x squared minus 3 equals 0. When we compare this to what we were given in the question, we see that a is 2, n is 5, and b is 24. In this question, all measurements are in meters. The diagram shows a right-angled triangle. Show that 5x squared minus 12x minus 27 equals 0. When we apply the Pythagoras theorem to the triangle, we get 6 squared equals x squared plus 2x minus 3 all squared. When we expand 2x minus 3 squared, we get 4x squared minus 12x plus 9. X squared plus 4x squared is 5x squared. When we move all the terms to one side of the equation and group like terms, we get 5x squared minus 12x minus 27 equals 0. Solve 5x squared minus 12x minus 27 equals 0. Show all your working and give your answers correct to 2 decimal places. To solve this equation, we can apply the quadratic formula. When we apply the quadratic formula to the given equation, this is what we get. The numbers under the square roots, negative 12 squared minus 4 times 5 times negative 27 gives us 684. And for the denominator, 2 times 5 is 10. For the first possible value of x, we get 3.82 rounded to 2 decimal places. And for the second possible value of x, we get negative 1.42 rounded to 2 decimal places. Calculate the perimeter of the triangle. We need to plug in the value of x in the dimensions of the triangle. The length of a shape cannot be negative, so we use the positive value of x to get the base and the height of the triangle. And so the perimeter of the triangle is equal to 6 plus 3.82 plus 4.64 meters, which is equal to 14.46 meters. Calculate the smallest angle of the triangle. The smallest angle of the triangle is opposite the smallest side of the triangle. The smallest side of the triangle is 3.82. We've labeled the angle opposite this side as alpha. To get alpha, we apply SOHCAHTOA to the triangle. This gives us sine alpha equals 3.82 divided by 6. When we make alpha the subject, this is what we have. When we type this into the calculator, we get 39.5 degrees rounded to 1 decimal place. Find h of f of 8 over 3. First, let's find f of 8 over 3. To get f of 8 over 3, we replace x in f of x with 8 over 3. This gives us 8 minus 3 times 8 over 3, which is equal to 0. To get h of f of 8 over 3, we replace x in h of x with f of 8 over 3, which we found to be 0. So we have 2 raised to the power 0, which is equal to 1. Find g of h of negative 2. First, let's find h of negative 2. To get h of negative 2, we replace x in h of x with negative 2. This gives us 2 raised to the power negative 2, which is equal to 0.25. To get g of h of negative 2, we replace x in g of x with h of negative 2, which we found to be 0.25. So we have 10 over 0.25 plus 1, which is equal to 8. Find g inverse of x. First, we replace g of x with x and replace x with y. Now we need to make y the subject. When we make y plus 1 the subject, this is what we have. When we subtract 1 from both sides, we get y equals 10 over x minus 1. This expression we have for y is the same as g inverse of x. So g inverse of x is also equal to 10 over x minus 1. Find f inverse of f of 5. Whenever we are finding the inverse function of the same function, as in this case, the answer is whatever is in the bracket, which is 5. Write f of x plus g of x as a single fraction in its simplest form. We've been given f of x as 8 minus 3x, and we've also been given g of x as 10 over x plus 1. The LCM is x plus 1. For 8 minus 3x over 1, since we multiplied the denominator, which is 1, by x plus 1 to get the LCM, we also need to multiply the numerator by x plus 1, which gives us 8 minus 3x times x plus 1. For 10 over x plus 1, since we multiplied the denominator, which is x plus 1, by 1 to get the LCM, we also need to multiply the numerator by 1. So 10 times 1 gives us 10. When we expand 8 minus 3x times x plus 1, we get 8 plus 5x minus 3x squared. 8 plus 10 is 18, so we have 18 plus 5x minus 3x squared over x plus 1. A, B, C, D, and E lie on the circle center O. Angle AEB is 35 degrees, angle ODE is 28 degrees, and angle ACD is 109 degrees. Work out the following angles, giving reasons for your answers. Base angles in an isosceles triangle are equal. To get angle EOD, we subtract 2 times 28 degrees from 180 degrees, which gives us 124 degrees. The angle subtended by chord ED at the center is twice the angle it subtends at the circumference. So angle EBD is half of 124 degrees, which is equal to 62 degrees. In addition to angle EBD, chord ED also subtends angle EAD at the circumference of the circle. These two angles must be equal, so angle EAD is also equal to 62 degrees. Work out angle BEO. Opposite angles in a cyclic quadrilateral must add up to 180 degrees. So we have angle BEO plus 35 plus 28 plus 109 equals 180. When we make angle BEO the subject, we get 8 degrees. In a regular polygon, the interior angle is 11 times the exterior angle. Work out the number of sides of this polygon. Here is the formula for the exterior angle of a regular polygon. We are interested in finding the number of sides n of the polygon. When we make n the subject, this is what we have. Now we need to find the exterior angle of the polygon. We are told that the interior angle is 11 times the exterior angle. So if the value of the exterior angle is y, then the interior angle is 11y. The sum of the interior angle and exterior angles must add up to 180 degrees. So we have 11y plus y equals 180 degrees. 11y plus y is 12y. When we divide both sides by 12, we get y equals 15 degrees. Now that we have the value of the exterior angle, then n equals 360 divided by 15, which is equal to 24. Find the sum of the interior angles of this polygon. Here is the formula for the interior angle of a regular polygon. So in this case, that will be 180 degrees times 24 minus 2 divided by 24. So to get the sum of all the interior angles, we multiply this by 24, which gives us 3,960 degrees. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.